Have you ever pondered if the very act of observing something can fundamentally alter its reality? This isn't just a philosophical musing. It's a central enigma at the heart of quantum physics. Our journey into this mystery begins with one of the most iconic and mind-bending experiments ever conceived, the famous double-slit experiment. Initially performed by Thomas Young in 1801 to demonstrate light's wave nature, this experiment has since become a cornerstone for understanding quantum weirdness. When light passes through these two slits, it doesn't behave like particles creating two distinct lines. Instead, it forms an interference pattern on a screen behind the barrier. This pattern, a series of bright and dark bands, is characteristic of waves interfering with each other, amplifying in some areas and canceling out in others. This vividly demonstrates wave-particle duality, a fundamental principle where light and matter can exhibit properties of both classical waves and particles simultaneously. This duality isn't limited to light. Electrons, atoms, and even molecules, when fired at a double slit, produce the same wave-like interference pattern. Now, here's where the experiment takes a truly mind-bending turn. The entire scenario changes dramatically when we introduce observation. If detectors are placed at the slits to determine which path a particle takes, the interference pattern on the screen mysteriously vanishes. Instead, the particles behave exactly like classical particles, creating two distinct bands corresponding to the two slits. It's as if they knew they were being watched. This profound shift implies that the very act of observation or gaining information about a quantum system fundamentally changes its behavior. When watched, even by an inanimate machine, a particle behaves distinctly differently than one that is not observed. This is the observer effect. This mind-bending phenomenon has led to various interpretations. One is that measurement forces the quantum system to choose a definite state, collapsing its wave function. The wave function is a mathematical description representing all possible states a particle could be in, along with the probabilities of finding it in each. Before observation, the particle exists in a superposition of all these states. But the instant a measurement is made, this wave function instantaneously collapses. Niels Bohr introduced complementarity, suggesting quantum systems aren't classical. Certain pairs of properties, like wave nature and definite position, cannot be observed simultaneously. Beyond the physics, the double-slit experiment carries profound philosophical implications, particularly concerning the fundamental role of information in the universe. Some interpretations propose that information is a fundamental aspect of reality itself, and observation is an exchange of information between observer and observed. This raises deep questions about the nature of reality, the role of consciousness, and the limits of human knowledge. Is reality truly objective? Modern physics continues to explore this experiment, even with increasingly large molecules containing thousands of atoms, confirming quantum weirdness isn't just microscopic. Variations like slits in time and the delayed choice experiment push these concepts further, delaying the decision to measure until after the particle has passed. These ongoing experiments reveal a cosmos far stranger, more intricate, and profoundly more interconnected than our everyday perceptions allow us to grasp. The law of observation and the double-slit experiment challenge our classical intuitions, inviting us to reconsider the very fabric of existence. So, what are your thoughts on this incredible phenomenon? How do you interpret the idea that observation can shape reality? Share your insights in the comments below.